Hi, Lamai. I hope that you can hear me clearly and see me clearly. Hello.
Yes, sir.
Okay. Today it is supposed to be a very new lesson. Actually, we started in the last week. I am going to remind you the very basics of that lesson because it is such an important lesson planned for us. So basically, I taught you what is momentum and how does the momentum affect. So, and I have to tell you one another important thing. Can actually like extremely sick today. So, but still I managed to do the class somehow. The throat is like almost like you have installed a certain grind or something inside that. It's like grinding feeling I have. So today I'm not going to speech you too. Everybody in my family, everybody except my mom and dad, everybody got sick, including the cat. We don't know whether the cat got the fever first and it spread to us, and we spread that to the cat. Somehow everybody got sick. So very unbearable, painfully throat out. So I request you. So not like in other days, I can't ask you the same thing whether you heard me, could you understand. So I'm not going to repeatedly ask you. So please be kind enough to respond me once I ask you, because I can't repeatedly ask you and repeatedly say the thing. So when you are writing a note, even so, write in the first time itself. Just give me some collaboration for this one, because not like in the last week. Last week I was really active and so highly energetic. Today it's like completely different version, negative side of the energy level I had in the last week. Not zero, even in a minus level now. So by the way, Formula Mighty. Okay. Typically in the last week, we kind of had like momentum and change of momentum. So students asked me for worksheets, even I didn't give you because I refuse to do that. One thing is we can't just give so much of calculations from that. It's very limited, but even the limited ones you might not be able to do alone. So you may need my help, because this is the first time you are just going to take the change of momentum. And including today, it will be covered up with important part called the law of conservation of momentum. You have never thought of, that part. Uh, the law of conservation of momentum is the behavior of momentum between two objects when it is collide with each other. So technically, I am about to show you what is momentum again when you have a certain mass of m which is moving at velocity of v. It can be anything. You just throw this marker, right? Mass of this one moving with velocity, and you punch at one of your friends for fun or actually with the rage somehow. The mass of the arm and the velocity, it will determine the amount of impulse or the vehicle just moving with slowly and faster. Momentum is higher. So it's like a roller. Rollers are like very heavy but moving in a very slow speed, but still capable of demolishing a very huge wall. Why? Even though the velocity is very low, but the mass factor is very high, so the momentum factor is too much high. I told all of these. And in a bullet is a very small one, very light stuff, but travel at a very high speed. So because of that extremely high speed, it gains really high momentum. due to that case, it will gain really kind of like a high momentum, right? So the momentum factor, I explained you in the last week thoroughly. It is P is equals to mv, and your unit is like kg ms minus 1, right? So these things are really easy. We did like a very simple calculations including as well. And I told you the very important part in that one is that is called change of momentum, because you have to find out the change of momentum for many future cases as well as even in the last week thing. So the change of momentum means you have to consider the inertial momentum. If it has a velocity, it might have a velocity of p1, or the velocity can also be 0, then p1 is going to be 0, or very low value to high value, very high value to low value, or very so high value to 0. There are the different types of things that you may experience as. So I can write this one as u here for the initial condition. So finally, you will just provide some force to do this, and finally it may gain some velocity of v and the final momentum of pf. So the thing is, you have to find out the change of momentum. As I explained in the last week, it is always the change is pf minus pi. pf minus pi. That is what we used to call as the change of momentum. Okay, have a really good look at here. So now I'm going to substitute these values to there. mv minus mu. So finally, it's going to be like m times v minus u. This is going to be your finalized stuff for what? Change of momentum. Okay, it's going to be your finalized thing for the change of momentum. Right. And I told you another thing. So the force is the rate of change of momentum. Rate of change of momentum. As I just told you, this is delta P. So the stuff becomes m times v minus u over t. So sometimes you have to remember this part. So this is what it became like f equals to ma as well. We have come across all of these parts in the Newton's laws of motion. And also I told you bouncing back. Bouncing baby. So the direction initially in this whole this case, the direction of initial momentum, the direction of the final momentum is the same. So whether it is accelerating, that means the object gaining extra force, or decelerating, you provide the momentum to oppose the motion. But here, the other thing is the bouncing back. Ah, you can show that appliance. Okay, wait. I will ask you in the right time. Right time to do that. The application of that one. Very good. I am also about to show you the way how to work that on. So let's do. Very good. මගේ 30 සතිය විලු කර කර හිටියේ ඔපරේෂන් හැංගිලා මොකද මේ එයා ලැජ්ජ හිතිලා එහෙම කියලා මම ඔයාලගේ අලුත් එක හිටියා. Okay, great. How will look at here now? So the change of direction may also occur. If the momentum of a system is determined by the velocity of u here in the certain direction of to right hand side, when it is bouncing back, so you may receive certain momentum in terms of v. I told you, you always take the direction of final as the positive. It will be really easy because you always subtract final from initial. So if you consider the direction of the final momentum, that will be really help you to do the calculations here. Have a really good look at the change of momentum. That means the final momentum minus inertial momentum. So the thing is going to be here, V final is mv minus, and I told you this is also going to be considered with the direction, that is as a vector quantity, since the vector is momentum is a vector quantity, mv minus mu. So finally you get like mv plus mu. So you can just get the finalized answer, v plus u. This one is also really easy. If the v is also as same as v is equals to u in terms of the magnitude, so the answer be what? 2 mu. You obtain these things. I'm just giving you a very quick recap about this. So, how many of you try these things at home? ගෙදරදී කී දෙනෙක් කරලා බැලුවද ඔය ටික ගාන ආපහු කියෝලා ගණන් ටික හදලා ලියලා කරලා ගත්තද? Okay, Savindra Dev did. Others? I think only Savindra Dev has done, went through the sums. Did, okay. Great. I actually need you guys to practice the same thing again and again. So by the way, so I told you another very beautiful thing, that is the angular change in momentum. When not angular momentum, if I say like angular momentum, it has a different meaning. You will learn in like 2 months from here. There is a lesson called angular motion, rotational motion, circular motion in that one. So you will learn that thing in the rotational motion part. There is a specific thing called angular momentum. That is not this one. This one means momentum change at an angle. That's how we have to say. Mu. I will just get this one in again u, but final thing I want to take as the positive one, while the initial one as the negative one. For our convenient, I told you why in the last week. If somebody missed the class in last week, please watch the video. If the angle is theta, this angle will be the same angle repeating over there. So this momentum u, mu, this one is going to be mu cos theta. So it is a negative one. So the bouncing back thingy, you can see the same angle. So this one is going to be plus mu cos theta. Along here, mu sin theta. Along here again, mu sin theta. And there is a new one, Navisan or someone. You are the only new one here, huh? Navisan, can you hear me? Navisan, are you there? Are you there in the class? Boy, Navisan, hello? Is that correct? Navisan or other name? I don't know how to pronounce that. I think I'm pronouncing in the correct way. In other boy. That boy there? Yeah, okay, that guy is there. So, can't you speak up, please? Make on the ගෑනු කතා කරනවා සමහර only very few students they speak. So Navisan, if you have no other problem like connection issues, stuff, coverage problem, okay, somehow. So you might be thinking that bugger is just TG, just drawing the things and explaining very fast. No, that's not my way. I'm just giving some recapture for the last week's lesson before starting today's part. If they have like some kind of forgetful things, so kind of like misconceptions, to remove those things. That's why I'm just speaking in a very fast way. The reason is I have to remind everything before starting today's lesson. Otherwise, if somebody having a very short-term memory loss, they'll just find really horrible at this moment. Okay. Now, along this direction, so you can see here, along the vertical, the change is mu sine theta minus mu sine theta. You subtract x by x is like if you subtract x from x, even numerically 5 by 5 examples 0. Somehow in the same way, mu sine theta minus mu sine theta, the final answer along this plane is vertically 0. Now you have to consider the horizontal direction now, horizontally. So the delta b, you have to go it like here, mu cos theta minus mu cos theta. The final thing is going to be 2 mu cos theta. In the paper class even I included one of these questions. ඒකෙදි මෙතන හිටපු උනුත් දෙතුන් දෙනෙක් නාගත්තා. එහෙමනේ. There were my students in my class rather than the external ones. But I know many, like 2 to 4 students really got stuck in the same exact question I included. නාගත්තනේ? අතුස්සන්න නාගත්ත කට්ටිය ලස්සනට හොම කරලා. You did? Ah, very good. Okay, guys. That's it. Oh, I thought another thing, අද තනිකර ගණන් හැදවිල්ලක් තියෙන්නේ. ළමයි එක දෙයක් මතක තියාගන්න. I have to tell you one thing. I told you physics is like a cricket game, not like tennis ball game. Firstly, you have to practice with plastic ball, tennis ball. Then have to practice with like in net practice with leather ball. Then finally you can play an international match against those very big named fast bowlers. Like in the same way, physics, in the first day you learn, you are learning something extraordinary. Then change of momentum. එහෙම ගොඩ දෙනෙක්ට නිකන් ඈ කොහොම දැනලා ඇතිනේ. අර අලුත් සින්දුවක් තියෙන්නේ කට්ටිය TikTok එහෙම කරන්නේ. तेरी बातों में ये उलझा जिया කියලා හොම නිකන් ඔළුව ගැන කියලා යනවා ඇතිනේ. That's normal. Because you never learned about change of momentum. So it will take some time for you to absorb, but you have to stay in the game. Game එකේ ඉන්න ඕනේ. අතහැරලා නෙමෙයි. අප්පා තේරුන්නේ නැත්නම් තේරුම් ගන්න ඕනේ. Only very special brains can understand in the same moment. Everybody is not special. Firstly, you have to understand one thing. You are not that special. If you are special, you have to understand that one too. Otherwise, you will be ended up like typical Sri Lankans. Sri Lankans, we used to say, අපි 2500ක් පරණ ජාතියක් ලිඛිත ඉතිහාසයක් තියෙනවා. We always talking about 2500 years ago things. Unfortunately, at the present, we have nothing. Right? මිනිස්සු කියනවා පොඩි කාලෙම අපි තමයි ලෝකේ තියෙන ශ්‍රේෂ්ඨම ජාතිය. අපි හිතන් ඉන්නවා පොඩි කාලේ. අපි ශ්‍රේෂ්ඨයි නේ නම් මහලුකුරු මහන්සි වෙන්න ඕනේ නෑනේ. Actually, we are in a very lower level internationally. So if we got taught that we are in a very lower level, but we have to step up. We have to say one thing, firstly understand, we are unfortunately dear students, we are in a very poor condition. We are not a powerful nation, but we have to be the powerful. Then the students as a mindset, they will begin to think, oh, ලංකාවේ නම පොඩ්ඩක් ගෙනියන්න ඕනේ. පොඩි කාලේ මෙන්න ලංකාව ලොකු වෙද්දී එක තේරුණාම පොඩි ඇරියස් මෙන්ටලිටි එකක් එනවා. ඔය අපි ඔය ගෙට්ටවත් එක නෑ අපෝ අපි සිංහයෝ. කොහොම කීකේ නටන්න දෙන්නේ. So firstly you have to understand what is your level. If you are really smart, you can to just understand that one as well. If you are really average or below average, somehow you have to understand who you are and keep practice. Normally in the second day you will understand everything. This is the second day, so you will understand how to make all the calculations. මම එකයි කල්පනා කරේ මම ඉද්දිම ඔයාලට හදවන එක හොඳයි mid week එකක් දීලා ඔයාලව නිකන් බය කරනවට වඩා කියලා. If that fear entered to your mind, then you shattered. ඉවරයි විනාසයි. අද බය නැති කරලා බය තියෙන ගණන් මෙතනම හදවලා ඊළඟ වීක් එකේ දෙන්නම් mid week එකක් ඇති සර් කියන එක. Sir, that's enough, no? Too much කියන ගන්නට දැනකන් දෙන්න. එහෙම හොඳයිනේ. හරි. There was another one I just taught you about a tube. that contain certain liquid like water, which is just flowing in a velocity of v, and the cross-sectional area is a, and this one has a density of rho. So the momentum, if it takes like t equals to 0 to t equals to t time, and the length traveled is L, how can you just link these things? So the momentum is, we know, m times v. We know this equation. We just did in the last week. So how to find out mass from density? Since we know density is equals to mass over volume, mass equals to density times volume. Isn't that? Yes. So this is volume, no, this is velocity v, this is volume v. I'll write that with capital V. In terms of this cylinder, we know that the volume is area into length. Area into length. Okay. So what is length? We know another thing. Length is equals to velocity equals to length over time. Length equals to velocity multiplied by time. So the volume factor becomes area into length into time. So finally, you can substitute here this one and, oh no, sorry, not this V, here. So the mass becomes rho A L T, right? Can I happily substitute it here? So the stuff becomes M, sorry, not M, no longer M, rho A, V is there with dot, area into length is what? Area, sorry, length into time is here. So this is about volume. Sorry, volume. And when we consider for 1 unit time, so you have to divide this by the time to find out the velocity here. So finally, that one is also velocity. So the momentum is rho A v to the power 2. So finally get momentum is equals to rho A v to the power 2. We obtain this one too. And sometimes you will get some calculations like this. I'm going to give you a certain calculations today itself. It is going to be plotting source. Again, පියාඹන පිරිසියක්. You throw small objects like this and let it hit against this floating stuff with some kind of having mass and n number of things under time of t with the velocity of v. So you will have to find out the amount of the speed, amount of number of balls per second somehow to hit the bottom of the plate to keep it floating. Good example is, have you ever tried keeping a small cherry on top of your lips and try to blow it like this? And it will just blow a plot just a few centimeters above your mouth. Have you ever tried that? So you provide what? The kind of change of momentum. Like in the previous case, you supply momentum of A rho v to the power 2 over 1 second. So if the force is going to be equals to this one, mg, you can just let it flow. මේ වගේ ගණන් හදන්න තියෙනවා. ඔහොම කිව්වට තේරෙන එකක් නැහැ. අද කරද්දි තේරෙයි. You will understand how to maintain that rhythm. Finally, I am going to teach you a very important theory part today. Just open a topic and write. That thing is impulse. 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 Okay, what is the impulse? Now write the definition. The product of force into time, the product of force into time during a collision, during a collision, during a collision is known as impulse. Right. It is like this, having a mass of m moving at velocity of u, it will collide against something like a wall or something. The collision may last for some kind of delta t changes of t of delta t, it will last for some delta t. So the amount of force exerted on the wall and on the ball itself, object itself, is going to be the same according to the Newton's third law pair. So both the forces. If I hit the whiteboard, I just apply a force against the black whiteboard, and the whiteboard applies a force back to my hand. So these two are with the same magnitude and opposite in directions. We know that. So somehow the magnitude is going. We have to multiply the force multiplied by this kind of like the time taken. So the impulse is equals to force multiplied by time taken. It is not a very long time like 5 minutes, 6 minutes. It's very simple amount. F delta t. So this is the equation for impulse. Now just can anybody tell me what is the unit of impulse? You have to write that with the topic of impulse. What is the unit of impulse? Can anybody name it from the equation? I have to check your units and dimension knowledge as well. Quickly. What is the, oh yeah, okay. Very good. I'm getting the answers. Very good. I'm happy. So finally, it's going to be Newton here and the seconds here. So the impulse has a unit of ns Newton seconds. Right. Right. So finally, in all the Scooby-Doo sessions, you have seen that at the end of the mission, the guy Fred, he always unmarks the villain. Api kawuda balamu meke inni? Like that, he open up. So finally, they find someone really unbelievable and person. They just normally believe him to be like a really good person, like that. So let's try to unveil who is this really impulse is. Now try to find this thing. Write this one in a double star point. Applying the basic form of force. Applying the basic form of force in terms of momentum. I told you the force is what? M delta V over delta T. So this is what? Change of momentum over change of time is the force according to Newton's second law of motion. The rate of change of momentum is the force. Now I'm gonna apply this one exactly on here. And let's see what is the result I'm getting. So I is equals to M delta V over delta T times delta T. So you can see a wonderful result now. Delta T and delta T cancel. So finally the units of, the form of actual hidden factor of this one is nothing other than M delta V. That means delta P. Impulse is nothing, the change of momentum. Can you just understand, or do I have to explain that again for the second time? Who understand? තේරුම් නැති කෙනෙක් ඉන්නවනේ ඕංගාලා අහන්න මම කියවන්න මගේ බුරි දෙනවා අද කතා කරන්න අමාරුයි වෛරස් තුනක් හැදිලා තියෙන එපා වෙන්න ඉතින් තේරුම් නැත්නම් මම ආයි 10 පාරක් අහන්නේ නැහැ so this is nothing but change of momentum මම ඕකටත් අහන එක පාරක් would you understand everything or not oh you have some connection problem and so the video is like okay I said like the moment sorry impulse topic is impulse I said like impulse is nothing but the definition the product of force into the duration of change of time a time of collision during a collision so if it is only valid for collisions you move and collide and finally t becomes like mv it takes like a time of t the force exerted during the collision is like f so the impulse is force into change of time, Newton into seconds, ns. So finally, I'm going to find out what is this force, the impulse in terms of momentum. So I apply like the change of momentum is m delta v over t. So m delta v divided by delta t times delta t and delta t cancel. So finally, you find the impulse as m delta v. So it is nothing other than delta p. I hope you understand. Guys, tell me. Right. Now write this thing in a new line. Impulse is nothing but change of momentum occur during a collision. Impulse is nothing but the change of momentum occur during a collision. Okay, have a good look at. I'm going to give you a very simple question now. Very simple. For a 5 kg mass, it exerts a force of 20 Newton, 20 Newton during a collision of 400 milliseconds. During a collision of 400 milliseconds. Find out the change of velocity during the collision. Find out the change of velocity during the collision. Now, just find out the answer. Just find out the answer. Okay. I hope the time is more than enough for someone to find this. I told you impulse is equals to force into delta t. And I also told you m delta v is equals to, instead of impulse, f delta t. Right. They asked here the delta v amount, f delta t divided by m is the answer going to be. Let's find out. It is 20 Newton. In time duration of 400 milliseconds. So it is like 400 you have to write, and into 10 to the power minus 3 to convert to milliseconds. And it is like 5 kg, 5, and it is going to be 4 here. 2 zeros going to cancel off with each other. It's like minus 1 here now. So the answer is going to be 4 times 4 is like 16, and minus 1 is delta V is 1.6 ms minus 1. Did you obtain this answer? Very simple calculation. This one it is. Okay, Raman. මේක තේරෙන්නේ නැති නේ මොකටද? පොඩි ගානක්. It's a very simple calculation. In A-level exam, even these type of very simple questions comes, and I'm going to show you that today. අද වැඩිපුර ගණන් හදන දවසක්. Now let's quickly move on to another theory part. Write this one in a triple star point and highlight three star C1. It's really important. Start to write this in a new line with the triple star. Area under the graph of a force versus time. Force versus time. Seconds, force in newtons. What is the area under the graph gives you? Tell me. What will it give? Area under the graph. If you are really smart enough, tell me. Area. How to find out area? The difference of force over difference of time. Force into time. What is that force into time? In this same graph. Inertia? Who the heck said that? Very bad girl. Okay. Yeah. Very good. Madrukshan good. Sarina good. No. that is a length into breadth. But I'm talking about in terms of physics. This height is y-axis. Change of y-axis gives you the change of what? Force. Okay, the force difference. Senura correct. And this delta y x-axis is along the horizontal, gives you change of time. So what is the product of time and force? I just taught you today, like 10 minutes ago, it is I inertia. Sorry, not inertia, impulse. Impulse. In the same lesson, you got I for inertia, I for momentum, change of momentum, or the thing called impulse. This is what the beauty of physics. Beauty of physics is very beautiful. So beautiful, so elegant. That's why that Indian aunt say, so elegant, looking like a wow. එහෙම නැත්නම් අර එදවස්වල ශ්‍රී ලංකන් බුවා අහලා තියෙනවා නේද? දැකලා තියෙනවා නේද? TikTok එහෙම අර බලලා නැද්ද? හරි ජනප්‍රියම එක්කෙනා මේ දවස්වල මොකද්ද කියන්නේ? එයා කියන ටෝන් එකකින් මම කියන්නම්කෝ. ඔයාලා මේ જાතිය ගණන් එහෙම හදලා නැහැ. Oh, so sad. ඒ වගේ ගණන් හදන්න නම් ඔයාලා ටීචින් පොස්ට් එකට යන්න. එතන හදනවා ලොකු ගණන් ලස්සනට. බලලා නැද්ද මිනිහෙක් වගේ අමුතු ඒවලට කියනවා. ඔයාලා ශ්‍රී ලංකනකින් කාලා නැහැ. Oh, so sad. බලලා නැද්ද? පුදුමයි දැකලා නැහැ කිව්වොත් එහෙම. ඒක මේ දවස්වල මාර හිට් එකක් තියෙන්නේ. ඒ මනුස්සයා දෙන එක්ස්ප්‍රෙෂන් නම් මං හිතන්නේ නැහැ. යුනික් මාර යුනික්. ඒක අපිට ගන්න දෙයක් හිතන්නවත් බෑ. highly talented dude. Oh sad. නියමයට ගන්නවා. Just check guy's name. I can't remember his first name, but the second name was something Senaviratna. So such a born talent he has. Okay, impulse. Oh, in the other way, it says like delta P equals to this graph. Area gives you what? Delta P as well. Or you can just write like M delta V is equals to area under the graph. කොහොමද නෝදා? මොකද වලට පස්සේ වලද්දී අමතක වෙනවා. ඒක නෝදා. You will forget these things in a different time. So sad කියන්නේ වෙන exam එකේදී. If you have forgotten these things, you have to say like, oh, so sad. Okay. Right. Okay. Let me just give you a certain calculation that you have to apply here. Let me erase this. The graph of, like this, graph of force versus time is shown during a batsman hits a run in a cricket match. Write this in a new line. If the ball is 150 grams, weight of mass of the ball is 150 grams. If the mass of the ball is 150 grams, 150 grams, and it took place for 200 milliseconds. 200 milliseconds. If the ball was coming at him, sorry, don't include that. Complicated වැඩි වෙනවා. So complicate කරි අඩු කරමු. කියන්න. Find out the change of velocity occurred of the ball during the impact. Force in Newton and versus time in seconds. 6 Newton milliseconds. Sorry, actually this is in milliseconds. Axis in milliseconds. Okay, try finding it. Until you find, I will just drink some water and come quickly. Area under the graph gives you what? M delta V. So here I have the area I can find using this triangle. Since you know the triangle, area of a triangle equals half into base is here like 200 into 10 to the power minus 3 into height of perpendicular height, that is like 6 Newton. Is your what area under the graph. And here it shows what M delta V. M is 150 grams, so it is like 10 to the power minus 3 multiplied by the change of velocity, that of delta V. Right, I have to go for delta V here. So I quickly write this in this manner. Sorry, minus 3 and minus 3 I can cancel off from both the direction. So 150 multiplied by this 2 is 300. So sorry, very sorry, I made a big mistake here, very big mistake. Okay, wait, I have to get this one. So 2 into 10 to the sorry, 2 into 6 divided by 2 into 150. So 150 cancel off. Wait. Uh, 51 over, so it's like 4 over 100. It's more like 4 over 100. It is like 0.04 ms minus 1. Did you find this answer? මේ answer එක ඔයාලට ආවද? Oh no, I made a mistake here. Sorry. Wait. 200 is here. I made a big mistake. 200 is there. It's not because I cut 200 somehow. 400 or it's like 4 ms minus 1. Very simple change of momentum velocity of that. Did you get this answer? Yeah. Good. Oh, sorry. 200 remaining. 4 ms minus 1. That's great. Okay, let me erase this part. Okay, shall I? Put it on. Okay, Lamai. Now the thing is a very big topic, very actually huge topic. Okay, very huge topic. Write this in a new line. The law of conservation of momentum. Law of conservation of momentum. Law of conservation of momentum. Can anybody tell me what is the meaning of law of conservation of momentum? Very simple. It has to be conserved. What is the meaning of conserve? Huh? So can you remember that there was a tree in Gampaha that, yeah, there was a tree in Gampaha. Then there was a lady called, I can't remember her name. So that lady finally kind of like intervened between that case, between the dispute between the government and herself, and agitating like public people, and also made a big argument about saving a certain tree called Pandukarandaga to construct that Northern Highway. So conserve, what is the meaning of conserve? How to save it. We don't let it loose. Simple meaning is don't let it loose. So the amount of the initial momentum is like this one. Okay, mark a pen, carrying some momentum, transfer some to this one and move away with together, or bounce back and this one is only moving, or both moving at two directions. There are multiple locations it may come. So I have seen many teachers, they derive certain equation very, that's a very horrible thing. I think it is not really good because students really think that is the standard role model. No. There is no such a model. There is no such a specific model for the momentum. Law of conservation of momentum. We have to get the basic idea. The initial amount should be thoroughly conserved during the collision or whatever happened. Good example is if the total momentum during the initial condition is like 10 kilograms per second, kg, ms minus per 1. So, or Newton seconds. During the collision, at the end of the collision, however, the amount should be always at any scale of the time, it should be the same 10 Newton second, 10 ns. I will just keep using the word called ns, just really easy, rather than using kg ms minus 1. It will take like 7 seconds, 7 to 8 seconds to pronounce that. But ns for the momentum, very easy. If you earlier had like 10 ns during the entire duration of the collision, it will be 10 ns at the beginning, at the middle, at the end, anywhere. It is 10. Example only. It can be in milli ns level to micro ns level to kilo, mega, tera, peta, extra. Very huge amount of collisions as well. ගණන් කරන්න බැරි තරම් ලොකු සහ ගණන් කරන්න බැරි තරම් පොඩි ඒවත් වෙනවා. So momentum is a universal lesson. So in all the like future lessons like all what modern physics, quantum mechanics is completely based on momentum. No. reduce වෙන්න නැති වෙන්න හේතුවත් එක්ක තමයි definition එක ලියන්නේ. So let's write the definition of this one first place. Let's write the definition. Law of conservation of momentum. You write the topic. If you wrote the topic, we can write the definition right now. Write the topic, definition. Unless an external unbalanced force is applied, unless external and unbalanced force is applied on a system, the total momentum of a system, the total momentum of the system remain unchanged. So you have to write this definition if it's asked in paper to write. So you have to go through all the topic points like unless an external unbalanced force is applied on a system, the momentum of the system is unchanged or conserved. That is the meaning of law of conservation of momentum. Typically, it is like initial momentum is equals to the final momentum. In words, you can write it like initial momentum is equals to final momentum. කිසිම equation එකක් එක්ක familiar වෙන්න එපා. Only this equation, nothing else. I have seen many teachers just give a model equation. That model equation is really bullshit, because if you find something other than that, if the student is only ready to apply in that model equation, then he or she completely done. There are like 100 ways to represent this. If you understand the very basic, before should be equals to after, or initial should be equals to final. That is it. Initial momentums can be applied in opposite to each other in the same direction. Only one provide momentum, or one at angle. So both collide and move in away with each other. So stick together and move in other direction. So one stop, other move. ඔය එකකට එකක් අපි ලියන්න ගියොත් එහෙම අපි පරදිනවා. So how can you remember all of these shit in your head? ඊට වඩා චුට්ටක් වෙනස් කරලා දුන්න ගමන් ඉවරයිනේ. ඒක නිසා ස්පූන් ෆීඩ් කරන්න හදන බබෙක් වගේ හැසිරෙන්න එපා. ඔයාලා ආසයි නම් මම එහෙම එක්ස්ට්‍රා වීඩියෝ එකකුත් හදලා දාන්නම් ඔයාලට ඕන්න. මම ආස නැහැ මොකද එක්සෑම් එකේදී A level වලදී දන්නවා කටපාඩම් කරලා එන කුක්කො ටිකට දෙන්න ෂොට් එක දෙනවම තමයි. ගිය අවුරුද්දේ එහෙම කරානේ සෙකන්ඩ් පේපර් එකේ. ෆස්ට් පේපර් එක නම් MCQ වල AC, සෙකන්ඩ් පේපර් එකේ දුන්නා ඉතින් බඩගගෙන අඬාගෙන යන්න. So in Sinhala medium, I'm not talking about English medium. English medium is not that corrupted. there are like basically two prominent teachers. They teach some kind of like easy physics. easy විදියට නිකන් අර කට පාඩම් කරලා ගුලි අඹරලා ඔබනවා. විනාසයි දැන් මම හිතන්නේ මේ සෙට් එකම සෙකන්ඩ්ස් අය යනවා රිවිෂන් වලට. ඊට වඩා හොඳ සීනියර් සර්ලා ගාවට. මොකද දන්නවා පළවෙනි පාර අර ගුලි කණ්ඩ ගිහිලා නාගත්තා කියලා. 21 2 දෙක සාමාන්‍ය විදියට දීලා බැලුවා අරුන්ගේ අර ස්ට්‍රක්චර්ස් වලට සෙට් වෙනවා. මොඩල් එක හදලා තියෙන්නේ. 23 එක දුන්නා මොඩල් වලට සෙට් වෙන්නේ නැති වෙන්න. මොඩල්ස් කඩපාඩම් කරගෙන ගිය එක විනාසයි. ඒ නිසා කවදාවත් ඔයාලා models නම් පාඩම් කරන් යන්න එපා. Don't ever try to depend on with the models, because how can you store so much of models in your head? In any way, you put all your effort and store all the shortcut methods in your head. In the exam, no model can tally with that. Then you have no practice for the critical thinking. දෙයියන්ගේ පිටයි 24 හම් වෙයි හොඳටම critical thinking එකක් 25ට දෙයි ඒ දිලා යන්න මොකද in the exam board they are our professors. Those professors are really smarter than any of the teachers. මම ඇතුළු ලංකාවේ ඉන්න ප්‍රසිද්ධම කෙනාගේ ඇතුළු හැමෝටම වඩා එතන ඉන්න පැනල් එක හරිය smart. They know what is the trend currently. They study those things that they have practiced. Others are just practicing. They want to avoid that. Otherwise, there will be unavoidable A count. That it has to maintain the standard. Then what do? They make a different structure and set the paper. විනාසයි. ඒක නිසා පොදාවත් ස්පූන් ෆීඩ් නම් ගන්න එපා. මම හැමතිස්සෙම කියන්නේ ඒකයි. ඔයාලට කනට හරි ලේසි අහගෙන ඉන්න ස්පූන් ෆීඩ් කරද්දී ඔයාලගේ අතට හරි ලේසි ඇහැට ලේසි ටික කාලයක්. මාස 5ක් යනකම්. ටර්ම් ටෙස්ට් හරි මැද හරියට සෙට් වුණාට පස්සේ බඩුම තමයි. අපි අර ඊසි මෙතඩ් එකට පුරුදු වෙන්න කෙනෙක්ට ආපහු හැරෙන්නත් කාලයක් බැඳගත්ත යකා ඔහොම බැඳගෙන ඉන්නවා වගේ ඉන්නවා එල්ලිලා. ඒ වැඩේ කරගන්න එපා. කැමති නම් ගිහිල්ලා කරගන්න. ඒකට බාධාකුත් නැහැ. මම මොඩල්ස් ටික ආසයි නම් කියලා දෙන්නම්. හැබැයි එක මොඩල් එකක් මතක තියාගන්න හදන්න එපා. It is a sin. It is completely a sin. If you try to remember these models, it's cardinal sin. So try to understand each model. That's perfect. Study the model and try to understand, but never try to remember these models. පොඩ්ඩක් එහාට පන්නලා දුන්න ගමන් ඇඳි ගෑවිලාම යනවා. Just write this one and I will bring that conservation of thinking. So the basic, very basic equation, everybody try to spoon feed. Now I am going to do the same thing with you. An object M1 which is moving with V1 collide with another object which is at stationary velocity of 0, M2. After the collision, you can see this one stops. M1 stops and M2 gain all the momentum and moving away with V2. This phenomena is only valid for this scenario. Useless to remember. But this can be applied in many calculations. ගොඩකට set. හැබැයි හැම එකකටම set නැහැ. So the thing is, Pi, as you know, M1 V1 plus M2 times 0. Pf is equals to M1 times 0 plus M2 times V2. Equation number 2, equation number 1. So we know that equation number 1 is equals to equation number 2. 0 is going to be nothing. So M1 V1 is equals to M2 V2. This is the most common model equation. මම හරි අකමැති දෙයක් මොකද that is why I wrote it like in an emoji. See, his mouth is really horrible. Now see teardrop, another teardrop, and head is like really fuming, right? So actually it is M1 V1 and M2 V2. Okay. I'll bring that other object. Operation with Avisa, I also expect you to prepare your one. Also, you demonstrate from your side. I am going to demonstrate it from my side. Let's see it. Haridramai, are you ready? So I removed the pin from here. Whoever speaks will appear. So I will only ask operation to speak because I remove the pin. Yes, yes. In the first diagram, it is about PI. In the second diagram, it is about PF. Hari? මම දන්නවා ඉතින් ළමයි සාමාන්‍යයෙන් මේ වගේ අමාරු ලෙසන් එකක් ආපුවාම ටිකක් ඒක අමාරු නෑ. චුට්ටක් ඒකත් එක්ක සෙල්ලම් කරපුවාම දවස් දෙකක් ඒක හරියනවා. එකපාරට ඔළුවට යන්නේ නෑනේ. අනේ මට මේක තේරුන්නේ නෑ. මම යනවා කියලා ලියුවෙවි යනවා. ඔක ඉතින් මට අලුතෙන් පුරුදු වෙන්න දෙයක් නෙමෙයි. මම දන්නවා ඉතින්. ඒ කියන්නේ මම කියන්නේ කිව්වේ මේක IQ එක තියන අයට විතරයි මේක හරියන්නේ කියලා මටත් ඕන නැහැ. ඉතින් බොරුවට ඔක බබා කරලා ඉමින් සීරියෝ එක දිගහැරලා රබර් කරලා ගෙනියන්න පුළුවන්. එහෙම කරලා මම අම්බ කරන් කණ්ඩ ආස නැහැ. මං ආස ඇත්ත විදියට උගන්නගෙන යන්න. ඕන නැතිම හිමින් සීරියෝ. Okay. You can see this diagram now. In the first one, it is the M1 multiplied by V1. It will give you the initial momentum of PI. And in the same way, have a good look at. In the second one, it is M2 and there is no velocity lamai. Then what is the thing? There is the momentum of 0. Now what I am going to explain you is P1 in the first condition, M1 multiplied by V1 plus M2, and it is the velocity of 0 here. This is what my equation number 1. I will consider this condition as the initial condition that of Pi. Okay, in the same way, okay, now write this thing as a very new point, very important. කියලා මේ ලයින් එකත් එක්ස්ප්ලেইন කරලා මේ ලයින් එකත් එක්ස්ප්ලেইන් කරලා මෙතෙන්ට එනවා බඩුම තමයි. එහෙම ඕනේ නෑ නේද? හා මම ආස නෑ එහෙම අර ට්‍රාන්ස්ජෙන්ඩර් වොයිස් එකක් අරගෙන එහෙම කතා කරලා ඒක කරන්න. හරි. මම කරන්නම් හරි විදියට. Have a good look at in the first one I am going to move this one. Okay, when it will just come and oh you need permission. අද සඳුනි මේ පිස්සුවක් කියලා මේ මට කෝඩිනේටර් එක්ක දැන් ඇත්තමයි මනුස්සයර මම බැන්නේ නෑ අහිංසක මිනිස්සෙක් කියලා. මම දාම පිස්සුවක් ඉන්නවා දැන් මම ලින්ක් එක හදලා තියෙන්නේ host මේ කෝ host දෙන්න බෑ ඊළඟට permission දෙන්න බෑ මොන මගුලක් කරලාද මන්ද මට තේරෙන්නේ නෑ. වෙනදා හදන විදියට නෙමෙයි. මම ඉන්න බෑනේ මොකද්ද මේ කරලා තියෙන්නේ බෑ.
Something has terribly done here. Give me 1 minute. So unfortunately, there is no way in the next week you can demonstrate here. So I will demonstrate only here today. When I just release, it will just hit the first ball with some momentum of mv. So the momentum carried by only a one ball, I told you the initial momentum should be equals to the final momentum. Initial momentum, whatever the initial momentum, it can be like example 10 kg nms minus 1 or 10 newton seconds ns. In the final momentum also 10 ns. So if a one ball comes, it carries the momentum that can carry at the time. So the transport momentum will also get the same amount, no more or no less. Have a really good look at now. When this one hit, only one ball leave from here because this ball only carried momentum of equivalent to one metal ball. Have a good look at. මේක අතේ තියන් ඉන්න හින්දා ඉක්මනට බහින්නේ ටේබල් টොප් එක තිබුණා නම් සෑහෙන වෙලාවක් තියෙනවා. Momentum will be absorbed by my hand even. See, only one ball. Now I am going to hit this with two balls. You can see now only two balls leave from here. Now have a good look at. Only two balls. Now I am going to do that with three balls. See, it will only moving with three balls. Now I am going to do that with four balls. It is not that successful. But somehow I'm going to show you that again with first ball. See, only one ball. Okay. I hope you understand what I'm talking about here, because you can also demonstrate this thing at your own home with if you can find very plain surface of a tabletop without table clothing, plain table cloth and with no rough surface. It should be very smooth surface like a carom board type of thing is well suitable. So you can also do a certain simple experiment. So that experiment is going to be a very simple one. Let me explain you. You can arrange few similar 1 rupee, another 1 rupee, another 1 rupee, or 5 rupee, whatever, one window on in a array, honey killing. Then you let it hit with another 1 rupee coin. And you can see not extremely faster, slowly. Sorry. This one will hit. As a result, this one will also merge with this set. This one will leave with velocity of some velocity of v. If you do that with two of these, two of these, what would happen? Two of these will attach to here, two of these will leave. Like the same way you can do that with many coins, and you can demonstrate this in your own hand and get to know very well, perfectly about law of conservation of momentum. Understand? Also remember one thing, initial momentum is going to be always the final momentum. Initial momentum will be equals to the final momentum all the time. I hope you understand this. Other? Yeah, Now we can't use this in a common condition like M1, V1, M2, V2 only for just a vague remember. නිකන් යාන්තම් නිකන් මතක තියාගන්න එක කරගත්තර කමක් නැහැ. Just a kind of memory. M1, V1 equals to M2, V2. Like that. M1, V1, M2, V2. But don't stick to that because it's very dangerous. Now different conditions like this. Imagine one ball. I'm not giving topics even for this one. Topic going to hit with something M2 velocity of 0. Velocity of 0. For the initial condition. This is for what? Initial. Now the final condition is going to be both of these two attached together. M1 and M2 attached together and move off with the velocity of V2. Now you can see, now you can't apply the same equation again. It is a different thing. Stick together. This is the final condition. This is the initial. This is the final condition. Okay, if you want to just write an object of mass M1, which is moving at velocity of V1, that is collide against an object of mass M2, an object of mass M2, which is at rest, Finally, these two objects stick together. And again, fix, move together, right? Stick together and move with the common velocity of V2. Let's write with the conditions. We know Pi should be equals to Pf. Pi is what? M1 V1 plus M2 times 0 is equals to මේ වගේ අතින් ලියාගෙන ගියොත් හරි ලේසි මොඩල් වලට යනවට වඩා. What is the final condition? You can see these two are attached together. M1 plus M2 attached together multiplied by V2. So this term is 0. So the finalized condition is M1 V1 equals to M1 plus M2 times V2. මම කියනවා මේ එකක්වත් කඩපාඩම් කරන්න එපා මේවා මොඩල්ස් හැටියට ගන්න එපා. Don't try to remember these as models. එක ඔබ්ජෙක්ට් එකක් ගිහිල්ලා වැදිලා දෙන්න එකට යනවා නම් මෙහෙම. එහෙම කඩපාඩම් කරොත් දෙයියෝ සීවෙයි. කැමති නම් කඩපාඩම් කරන්න. මම කියන්නේ එපා. මම models ටික දෙන්නම්. But don't ever try to remember the models. It's dangerous. Now write the, did you copy this one? Okay, quickly. Now write this one. Another condition, a mass of M1 moving at velocity of V1 is colliding with another object which is moving at V2 in the same direction. Which is moving at the same direction. Okay, moving at V1 in the first direction. V2 is also moving at the same direction. It is like this. This one was moving like this, other one going behind. It is like that minister who crashed against that container in highway. Container was moving here. The minister's vehicle came here and passed. Then stick together and move as a single object. Okay, now be wise enough. Now I'm asking you the questions. In the first one, it carries, I will mark this one as A, this one as B. It will carry its own momentum of PA. This one carries momentum of PB. So since vector momentum is a vector quantity, you have to consider all these sum together. Okay. What should be the initial condition now? Because both of them are contributing in opposite direction or same direction. So the thing is, have a good look at Pi is equals to M1 times V1 and plus M2 times V2 in the same direction. Always put these arrows to recognize the direction. Equation number 1. Another, say yes if you understood. Yeah. මේ මම theories දෙනවා fast වැඩිද? ඔයාලට තේරෙන්නේ නැති තරම් fastද? Am I teaching so fast? ඔයාලට තේරුම් ගන්න බැරි තරම් ගොඩක් fastද? එහෙම නෑනේ. ඇත්තටම මම ඇත්තටම බැලුවොත් අපි හරිම slow. We are actually very slow compared to before COVID conditions. Before COVID, the entire mechanics is done by now. We should be in other lessons called waves now, middle of waves. Unfortunately, after COVID, everything upside down. So now for the final conditions, we know M1 and M2 move together as a single object with the velocity of V3, sorry, this is V3. So you can write M1 V1 plus M2 V2 equals to M1 plus M2 times V3. Then තේරෙනවා නේද මේවා කටපාඩම් කරලා මතක තියාගන්න පුළුවන් රජෙක් මේ ලෝකේ නැහැයි කියලා. There is no one can remember all of these in by heart method, but unfortunately I can't. You can, it's really better. But if you find something critical thinking, baduma thamai. So copy this. හරිනේ. තව කරන්න පුළුවන් මෙහෙම දේවල්. මම යන්න එකටම මොඩල්ස් දෙන්න යන්නේ අපරාධයි. නේ? Two objects colliding like this and bounce off again like this. So in that case, do I have to add these momentum together or subtract? Am I supposed to add these together or subtract? Tell me. Definitely do subtract. See, collide, subtract, collide, subtract. For the initial condition, the final momentum will be conditioned according to that. Final adu vela enne. Some vector sum, you have to consider the vector sum. අනේ මට definition එක දෙද්දි එක වචනයක් මිස් වුණා මට දැනුයි මතක් වුණේ. I said like can anybody just read out the definition? මට direction ගැන කිව්වේ නෑනේ. direction කියන්න අමතක වුණා කියලා මට දැනුනේ මතක් වුණේ. Can anybody read the definition please? Madhuruksan, please. Anybody කිව්වොත් මේ ආත්මෙට කරන්නේ නැහැ.
Unless an external force or unbalanced force applied on a system, total momentum of system remained unchanged or conserved.
Okay. External and unbalanced force is not applied in a system along specific direction. Along specific direction. අන්න ඒක දාන්න ඕනේ. Along specific direction. So we have to consider horizontal at a time and vertical at a time. So it's directional. And there is a third dimension as well. We are not talking about that. X, Y, and Z. But firstly, in the X direction and the Y direction, you have to add after, like, when there is no external and unbalanced force applied on a system along a specific direction. Along a specific direction. Just add that to the definition. You have to consider the direction. Right? We only consider the horizontal and the vertical as well. We have to consider that vertical and horizontal together is out of syllabus. But let's practice, because the school term test papers, you may get it in the A-level conditions, is out of syllabus. But I'd like to teach you, because in term tests I have seen many. Why are we taking a risk? Ne? ගෙදර ලකුණු අඩු වුණොත් අනේ මේක සිලබස් එකේ නැති දෙයක් අප්පා පේපර් එකේ දීලා තිබුණේ කොහොමද අම්මලා පිළිගන්නේ නැහැ. යාළුවා සතුටු කරන්නත් එපායිනේ. එතන අන්තිමට කිය යද්දතොට කිව්වා මම ඔන්ලයින් ක්ලාස් කියා කියලා එකටත් පැනලා මටත් පැනලා ඔයාලටත් පැනලා එන ප්‍රශ්නයක් වෙයි. ඒ නිසා ටර්ම් ටෙස්ට් ටීචර්ස්ලා දෙන මොංගල් ගණන් වලටත් වැඩි වෙන්න ඕනේ. old syllabus එකේ තිබිලා තියෙනවා. ඒකයි ඔය සීන් එක දාන්නේ. old syllabus. ඒ කියන්නේ මම කරපු සිලබස් එකටත් ඕල්ඩ් දෙතුන් පාරක් ඕල්ඩ් වෙච්ච එකකට තිබිලා තියෙනවා. අපිට තිබුණෙත් නැහැ. ඔයාලට කොහොමද? There are very old people still in practice. They teach even as the young generations. We just used to learn the same thing. So the young teachers also try to keep applying the same thing. So monkey see and monkey do. Who cares? අපිටත් monkey scene එක දාන්න වෙනවා. Do you know that thing? Rituals. So in the scientists just carried out certain experiment using monkeys. So they just keep removing the monkeys from the stuff. So firstly, they just kept monkeys hunger and just hang certain banana stuff self in a top of just a kind of like a ball inside a cage. So one monkey is trying to grab it. Other monkeys are just going to do what? Fight with that monkey to get that. If that monkey tries to do that, other monkeys are just dragging his legs downward and somehow win over. This process carried for a few weeks. Then only few monkeys kept in the cage. Other monkeys were dismissed. So they still keep certain banana. All the monkeys were just attacking the other monkey who was trying to do that. So all the monkeys were removed. Now the ritual will still in practice, but the foods are everywhere. Food is everywhere, but when someone tries to get the banana in the top that pole, it get attacked. Even the food is everywhere. Why? They thought it as a ritual because monkey see, monkey do. Large tuition class වලත් ලෝක තමයි වෙන්නේ. යනවා සෙට් එකම යාළුවෝ කඩාගෙන අරුන් ටික රස්වාව මාස් දෙනවා බා. පොඩි ෆන් එකක් ගමු. දීලා ෆන් එකක් ගන්නවා. ෆන් එකක් තියෙන්න ඕනේ. හැබැයි ඉගෙන ගන්න ඕනේ අංක එක. Right, okay. Monkey see, monkey do. Right. All the things I want to teach for today is completely over. So we can stick to calculations From today onwards, I can give you hundreds of thousands of calculations, and I have to give you another important theory called elastic and inelastic collisions. We learned many theory so far, so it is really painful to learn all the theories straight away. So I decided to give you like many calculations now, and before the end of the day, that before actually 11 o'clock, I'll give you that theory about elastic and inelastic collisions. You will have good experience in type of collisions even. That will be the most probable way, most useful way. Let's start to do the questions. Give me just few minutes left now. Hello, students. Can you hear me? Am I audible enough? Hello? Am I audible enough for you? Am I audible? Reply to the other device, please. Drop to this device. I'm sending a message now. Okay, Lamai. Uh, okay. So there are like almost 10 simple questions in the first page. I don't want all the stuff. I just need you to do the second one, fourth one, seventh one, and the ninth one. Only these four. So I will give you like 2 minutes for each. So the time allocation will be like 8 minutes. Recording is in progress. Give me a 1 minute. I want to just check whether I can just rearrange this participant joining thing. the waiting. No, can't off the waiting room. Shit. The momentum of a 3000 kilogram truck is no other one. Sorry. 0.4 kilogram object is moving in a frictionless surface with 30 ms minus 1. The force of like 2 Newton is applied continuously until the velocity of the object is reversed. How long was the force applied? It is a force thingy. So you have to apply it like how long? How long means the time. So the change of momentum m delta v, sorry, m delta v is equals to force multiplied by time. It is impulse, equation of impulse. So we know the mass is, it is like 0.4 kilogram, 4 kg multiplied by 0 is the final velocity momentum minus initial momentum that of 0.4 times 30. That should be equals to the final force into time. Force 2 is into time of t. The opposing force, this one, so it is a negative force. This 0. T is equals to 0.4 times 30 divided by 2. 0.2 is like 6. 6 seconds. You have to apply the force for 6 seconds. Did you get this answer correct? Did you get this answer correct? Okay, Raman. Okay. So velocity reverse mean, doesn't it become minus 30? No. It is like the direction changed. Okay. Velocity just reverse mean we can't just I think of like it up to what level? Direction එක change වෙනකම්. If to the same direction, we have to say like to the same level, reverse to the same level. If say like reverse to the same level, it is the thing. Velocity being reverse means the direction of motion changed. A force of 180 Newton acts on the 9 kilogram bowling ball. 9 kilogram bowling ball for 0.4 seconds. What is the change of velocity of the bowling ball? Right. The force of 180 Newton. So mass is 9 into velocity, I don't know, change of velocity, it's equals to 180 times 0.4. So the change of velocity delta v is equals to 180 by 0.4 divided by 9. And 0 cancel from here. It is going to be just 4. 2 times 4 is 8. Delta V is going to be 8 ms minus 1. Did you get this answer? Yourself? Hello? Yeah. Correct. Very good. I told you I'm not asking repeatedly. I asked you, if you don't reply, I'm not asking again. The force of 180 Newton is set on the 6 kilogram bowling ball for it. Here it is asking what is the change of momentum. It's 6 kilogram, different thing. Delta P should be equals to force multiplied by time. I told you this one has the second of set of equation in the impulse. I told you to write all 3 equations. The change of momentum is going to be the force 180 multiplied by 0.4. You get it like 18 times 4 is like 3672 kg ms minus 1, or you can write like ns Newton seconds, whatever. What is the change in velocity? Now you can apply this to the change in velocity part. 180 times 0.4, because I don't really rely on what my previous answers. If I did some mathematical scene, that scene will haunted here. So I would definitely stick on to the previous values. Right. 0.4 is equals to 6 times change in velocity delta V. How many sixes? 3 sixes, 0 and 0 cancel off here, like only 4. 3 times 4 is 12. The change of velocity is 12 ms minus 1. Understand? Now in the next one, the second question did by P equals to U plus AT and F equals to MAN, got the answer in 6 seconds. Yeah, you can apply that method as well, because I told you momentum and force are two different things. It is the same thing. Actually, this is the first law of motion thing. And second law of motion together. Sometimes third law also joining to here. These are like same thing actually. Two sides of a same coin. Similar. So you can apply F equals MA with V square equals to U square plus 2AS for the second one. No problem. But I practice that one with today's knowledge because I wanted to teach you today's one very often, because this is very easy. So see, these steps are very smaller than the other one. Very few steps, you can get the answer. So whenever you learn a new equation, that means physics is not getting hard. Physics is becoming even easier, because you know simple method to solve a very hard thing. Before a collision, 25 kilogram object was moving at 11 ms minus 1. Find the impulse acted on the object if the after the collision moves with the following velocities. Positive direction. with that much. I is equals to M delta V. Right. $25 times final is like 7 minus 25 times 11 is the change. Is I is going to be like 25 times minus 4. So the answer is minus 110s. Very simple. Now in the next one, impulse is equals to 25 times 11 minus, sorry, final thing is final minus 25 times minus 3. Sorry, 25 times 3 because I got the minus sign here. Minus 25 times 11. The answer is going to be 25 whole negative 25 times 3 and 11. It is going to be 14. 150 and 100. It is like 350 minus 350 Newton seconds. Very simple. Aren't these things very simple when they were lazy at that? Lazy at the yes. Okay. හරි. ඉන්ටර්වල් එකක් අනන්ත ටික කරනවද කොහොමද එක දිගට කරගෙන යනවා? කැමැත්තක් කියන්න. Whatever you would like we can do. මතක තියාගන්න මෙතනින් එහාට දිගටම මොක තමයි වෙන්නේ. During the first day of teaching it will be really hard. In the next day it will be cakewalk. පළවෙනි දවසේ තේරෙන්නේ නැහැ කියලා. ඒක normal because you are learning something for the very first time in all future lessons. Not like physics, not chemistry, not like biology, not like combined maths. You will learn very important but never asked theory for the first time. You will get the start, but if your brain capacity is very low, but high brain capacity people can understand in few seconds. Just they are blessed. But if you are with the general brain capacity, even in the next week, you can do it very easily. Your brain capacity doesn't matter in that sense. Even you are with the big brain, normal brain, doesn't matter. Right? So are we going about to take an interval or do this quickly tell me? Sure, 10 minutes then none.